Hi there, this is Mr. Ndelovet, your physics teacher. Today we are going to be looking at current electricity, specifically house or household wiring or house wiring. We're looking specifically house wiring or household wiring, how you can call it. So what's our objective of this lesson? Is at the end of the day you should be able to describe and draw a ring circuit. We should define a fuse. Be able to differentiate between fuse and circuit breakers. You should be able to identify the different cables and explain their purpose. You should be able to draw the 3-pin plug and is to calculate the fuse rating. So at the end of the lesson, you should be able to, describe or draw the ring circuit. You should be able to define fuse, differentiate between fuse and circuit breakers. You should identify different cables and explain their purpose, and draw the 3-pin plug and calculate fuse rating. Now, so let's begin. In every household, we use electrical energy. And where is electrical energy coming from? Electrical energy is coming from, let me change the color here. So electrical coming from hydroelectric power stations, right? That we have. And they are transferred from the power stations to our houses. So they are transferred through cables. And these cables are on high, they call it high tensions. And they're transferred, and then we have transformers, which is not connected to our houses. So the voltage here is 11 kV, very high, and when it reaches here, it's dropped to 240 volt. So the current that is flowing through this person is an AC current, or we call alternating current. So alternating current means, as I said before, the current that changes directions. It means that they're moving like this. So it means from here we have 240 minus 240, we have plus 240. So that's what we have. And in Cameroon, this AC current has a frequency of 50 hertz, meaning that what do we have? These lines, these changing directions, means that it changes direction 50 times in 1 second. That's what it means. It means that it makes this change like this 50 times in 1 second. So if I want to do this, I have to do complete. I have to make these things like this. I have to do this 50 times before I have what? 1 second here. So that's what we mean by having that. So when it comes to a house, what happens? It comes to our house, where you leave the transformer is being carried by cables back to our houses. So from the cables, you have a pole. and from the pole it's being transferred to our houses. Now, which cable carries this electrical energy to our houses? That's what we're trying to look at. Which one? We have two cables. So we have, for us to electrical wire the house, or we said electrical installation, arrangement of electrical installation in the house is what we call house wiring. So house wiring is the arrangement of electrical installations in houses. So house wiring is arrangement of electrical installations. Yes, electrical installations. So this current is carried from the poles or from the electrical board to the house using two cables, which we call the live and the neutral cable, right? So I'll just draw a simple diagram here so we can better understand what this is all about. Okay, so okay, that will be good. Let me see. Okay, so we have the this. So there's a live, there's a neutral. So let me present with the color so that it's easy. So you have a neutral, you have neutral, you have neutral, and we have live, live, and live. I have live here. So this is what we call the main switch. Is what we call the metal, electric metal. This is the main board, electrical board. The electrical board. So this is board fuse. And so all of this plus this. So these two components here, we call it the consumer unit. And we have, what we also have now, we have this, which is called the lighting circuit. This is the ring circuit, and this will have appliance. Sorry, my handwriting is poor. So we have this is a lighting circuit, this is a ring circuit, and this is what we call the appliance. So when light leaves the board, it's being carried by these two cables, the neutral and the live cable. And the live cable is carried by a live cable, so it passes through the metal. So this board has what we call the fuse, the electrical main board fuse, which protects metal for it not to get burned. So any current that is more that is coming than normal, this one breaks open so that it does not destroy the metal. So the metal now distributes the current to the main switch, which the main switch is found in the consumer unit. So the consumer unit contains the main switch and also contains circuit breakers that distribute the current throughout the whole house. Now, this consumer unit has circuit breakers for bulbs and for sockets and for appliances that takes a lot of current, like electrical cookers. Now, so the sockets and the lighting bulbs are connected differently. So the bulbs are connected using the lighting circuit, and the sockets are connected using the ring circuit. So that's what happens. They're connected using this ring circuit. So the lighting circuit, as you see here, the lighting circuit, it's a low current circuit that connects bulbs in parallel in a house, so that anything, if one bulb fades at the other, can continue shining, and they are protected by 5 ampere fuse, which is this. Now you also see that I'll use different colors here. For the neutral color, the neutral cable is always indicated by blue or black. Why? The live wire or live cable is always used by a red cable or a brown cable. That's why I've used red for live and blue for neutral. Then we'll learn about another cable which is called the earth cable, which is usually indicated by green. It's always colored green or yellow and green stripes. Those are the different cables. So this is how current goes into the house. So we are going to look at how to draw now the ring circuit. So we have learned that as a light leaves this part of the house, of the electrical board, it passes through the metal. From the metal, go to the main switch. From the main switch now, which is part of the consumer unit, is distributed to other parts of the house. And the consumer unit controls the distribution of light in the house. So we have the lighting bulbs, which have circuit breakers there in the consumer units that control the bulbs, that control the circuits, and also controls the appliances that needs a lot of current to them, right? So when we have, we have this one is 30 amperes, and this one is 30 amperes. So these are the different fuses. So we have seen that. So along this line, you see we have talked about fuses. What are the functions of fuses? What are the functions of fuses? What is the meaning of the ring circuit? How do they connect the ring circuit? That's why you have to look at it. What's the difference between fuses and circuit breakers? So let's look at that. And so now, and looking at that, so you see that we have now we are looking at that. So circuit breakers now, actually, circuit breakers or fuses. Let's start with fuses. Fuses are safety device. Have the shape like this. The safety device which melts and breaks off a circuit when a current more than normal comes in to it. For example, if the current of this was 5 amperes and a current like 5.5 is coming into a circuit. This man breaks off and disconnect the circuit so that current does not flow and destroy the appliance. So it's like it's a sacrificial lamb. So it sacrifices itself and dies so that the circuit or the appliance lives on. That's its function. Now, in how do we calculate this? In order to calculate, to know which fuse to use in any appliance, first you need to calculate the current passing through the appliance. For example, if you have a TV and the voltage of that TV is the power of that TV is 900 watt, and the voltage is, let's say, 30 volt. Now you have to calculate current passing through that TV. So current will be power over voltage, will be 900 watts over 30 volt. So this one cancels here 3, so you have 30 amperes. So that will be the current flowing through the TV. But now, so the fuse that you're going to use on that TV system will be something slightly above 30. So you can use either, if there's 30.5 ampere, that's what you use for the fuse. If there's 31 amperes, that's what you use. So if there's 30.5, this is what you use. But if there is not, you will use 31 amperes. So you use the one that is slightly closer to the value of the current that flows through that appliance. So that's how we calculate the fuse rating of any appliance. I go over again. The fuse is a safety device that has a wire in it that melts and breaks off the circuit when a current more than number passes through it. So for you to calculate the fuse, or to know which fuse you use in your system, you have to first calculate the current passing through that system. And for you to calculate the current passing through that system, first you need to know the power of that system or the appliance and know the voltage. When you know the current, then the fuse that you're going to use will be the value. You must have a value which is slightly above the current passing through that appliance. Like in this case, we say this 30 amperes. It means we either use 30.5 if there exists a fuse like that, or 31 amperes if there exists a fuse like that. Right. Now, there are also nowadays they use circuit breakers in houses. Now we have circuit breakers. Circuit breakers also are safety device which now switches off. Most houses have that. Switches off. Take note of that. This one melts. This one switches off. So the circuit breakers, let me put this way. Let me use, so this one switches off while this one melts. So this one switches off, this one melts. And when the current is more than normal, so all they have the same function, but they have different ways of operation, right? So the difference between a circuit breaker and a fuse is that this man switches off and cuts off the circuit, but this man melts and cuts off the circuit. So between the fuse and the circuit breaker, the one cannot be replaced. But this, you do not need to replace it. So you do not need to replace this man, but this man you need to replace it, because when it melts, that's it, you throw it. This man is very fast. It cuts the current very fast, it's very fast. But this man takes some time. So for you to easily identify current, it's faster and breaks off. But while the man takes some time, it delays a bit. And this man switches off, but this man melts to switch off the current. So that's what you need to know between this difference between the circuit breakers and the fuse. They do almost the same, have the same functions, right? And we also talk about the head wire. So the head wire I said it's always either green color or it's all yellow and green stripes. So if you have a green color, you see green color cable, that's a earth wire, and they're also protective. They used to protect the appliance or to edit not to get shocked if a fault develops in the circuit. So it's always connected to the ground or to the casing of the system. So if you have a system like this, it's always connected to the casing. So, and then it's connected to the live wire and then down to the earth. So all the time, when they always have it, they always have three cables in the house. We have the green, the brown, and we have the blue. Green, brown, blue, which means the green is the earth, the blue is the neutral, and the brown is the live. So you have earth, neutral, and live. So these are the different cables that we use in our houses. Right. Now, when you use these cables in your houses, now we always talk about, we're going to talk about the ring circuit. Now, the ring circuit, it's a domestic electrical wire system whereby the different outlets have their own fuses, right? All the you can see sockets have their own fuses, and they are connected in a ring shape. And if they are connected in the ring shape, it means that they do not meet, the live and neutral do not meet. And if one cable falls, if one socket or outlet gets bad, the other outlets keep working. And so this is how, so let's see how it draw, because in your exams you need to learn how to describe this circuit, and also you need to learn how to be able to draw it. So let me use another color. So in doing that, it's always having something like this. You have the main switch, and this main switch have the live and neutral cable. The live neutral cable comes. So let me say this is live. It comes. So in this live, there always need to be a fuse. So there comes, it breaks, opens, something like that. Now we have the neutral cable coming. That's a neutral cable. Neutral cable comes, it goes, it breaks open too. Now we have the edge cable, which is connected like this. Now you see, now we have this one is a live, F, neutral, live, live, F, no, neutral, and F. So you look at all this, so you see that all these now can be connected to an appliance. So you have a socket this way, it has 3 holes. You have one, 2, and 1. So this one is the head goes here. Now the live goes, and the neutral goes. How you connect it? So you can have another socket here. They have F, live, neutral. So you see the F goes, the neutral goes, and live goes. So this is how we connect that to circuits. So you have different circuits like that. So this is the main switch. So you need to learn how to draw this circuit in your exams. So this is how the main switch looks like. And you need to understand that it's electrical system where this all these sockets or these outlets that we have around have have their own fuses, and they are connected in a ring. See, all of them are connected in a ring. They're connected in a ring. So if one socket gets bad, this one continue functioning. So that's what you need to know. I need to know how to draw it. I need to know how to describe it, right? And each of the outlet have their fuses, and they are being this ring is being protected by a fuse on the main switch, which is this one. Yes, so that's what we mean by the ring circuit. So the ring circuit is a circuit that controls the sockets. The lighting circuit is the one that controls the light bulbs, and the appliance circuit is the one is for just for the appliances that takes a lot of current, like electric cookers in your houses. Now, and some people will be asking, now we have, yes, we have known how to this how the electrical wire system in the house works, but now how can we be able to read a meter in a house? Because the meter, what does it do? It measures the electrical energy consumed by the participants or by the people living in that house. How do we consume? How do we measure them? So if you look at this, actually, for example, if you look at this, like this is example of a metal. This is my metal in my house, and I just read this a reading. If you look at this, the board. Now I took this reading on the 11th of September 2025. If you see that this is 3,802 kilowatt hour, that's what I've consumed by this date. The last time I read this thing was last year on December 23rd of December. So it was 3,440 kilowatt hour. So if we take 3,440 kilowatt hour, subtract from this 3,802 kilowatt hour, you will know the total energy I have consumed, and we have consumed for that year or for that period. And if you multiply that by the cost of 1 kilowatt hour by new, you will see that it will tell you the total amount of money I'm supposed to pay to Inyo for the consumption. So that's how you connect it. Okay, so that's it. And so that's what we mean by that. So I think by this time you should have understood what the different colors of cables. You should know what a fuse is. Should know what a circuit breaker is. You should know the difference between fuse and circuit breakers. If you know how a current flows from the electrical main board to the metal, to the main switch, and to the different components which you have, the lighting circuit, the ring circuit, and the appliance. And you also understand that the consumer unit is made of the main switch and the other circuit breakers of the lighting circuit, the ring circuit, and the other appliance. Right, good. So if you understood that, then that is great. It means that you have understood the lesson. Now, more videos will be coming up. I'll give you more detailed explanations which you can help you even copy notes on these lessons. So, but if you want more guidance on physics and lessons like this, I'd like you to get the link below, and so you can come to my, you can join my group so I can better help you to understand physics and better and have better A's and better grades in physics. Okay, have a wonderful day.